ones in the text which I thought was kind of interesting was this one. So it had this function here, 2 cos squared x plus 2 sine squared x plus 1. And it said find the derivative of this function. So let's go through and do that. It might be a little bit confusing at first when you first see this notation, this cos squared x notation. Until we get used to it, it might not be overly obvious that that's a chain rule question. So if I rewrote it like this, which would be a more traditional way of writing cos squared x, it's more obvious to me that, oh, that's a chain rule question, just like other ones we've done. So I'm just going to do that to start with, because that is quite an unusual notation. All right, so now when we find the derivative, I should actually label that, shouldn't I? That's f of x. That is also f of x, just written differently. Now let's find the derivative. So we apply the chain rule. 2 times 2 is 4. And we don't change anything straight away. That's cos squared x to the power of 1. And then we times it by the derivative of what's in the brackets. So that would be a minus sine x. Okay, so that's the first term done. Now let's go to the next term. 2 times 2 will be 4, of course. Don't change what's in the brackets. And that's now to the power of 1 times by the derivative of what's in the brackets, which is cos x. And the plus 1, the derivative of plus 1 would be 0. So we have found the derivative. Now, at first glance, you might think, well, that just looks like, you know, that doesn't look particularly fascinating at this stage. Before we look at the next step, which makes it quite obvious what happens, let's actually have a look at the graph. So if we actually look at the graph, this is the graph of the original function. You're probably expecting something curvy with all the coses and, you know, something that looks like a sine curve or something like that. Let's have a look what it actually looks like. There it is. It's a straight line. In fact, it's 3. So what we, and the derivative of a straight line would be 0. So what's going on there? Let's go back and have a look. This guy here, the f of x, up the top here, this is just a really complicated way of saying f of x equals 3, which we'll have a look at in a second. But let's just show that the derivative is equal to 0. If I just tidy this up a little bit and go 4 cos x times minus sine x, well, that's minus 4 cos x sine x. And this one here is plus 4. I'll just put the cos first to make it more obvious, cos x sine x. If I've got minus 4 cos x sine x and then I add 4 cos x sine x, we end up with 0. All right, so why is that the case? So I'll just make a little bit of room down here so I don't need to go to a new page. If we go back to our top function there and we just factorise the first half by taking out the 2, so I would have 2 bracket cos squared, whoops, where have my s, cos squared x plus sine squared x plus 1. What do we know cos squared x plus sine squared x equals? 1. Yep. Cos squared x plus sine squared x equals 1. That's one of our identities we do need to remember. So we've got 2 times 1 plus 1. So as I said, that is just a really complicated way of writing the number 3. So if you want to do that to impress your friends and relatives, that'd be a fun thing to do on the Easter weekend.